Hi, welcome back to the build. This segment is about the unique control system that I'm putting into the TÜÜB board. In my case, it's gotta be unique, because my arms have a lot of problems with repetitive motions. That rules out all the different kinds of hand-operated remotes, because, as you can see, they just give me pins and needles everywhere. So, what hands-free options are there? Weight shift control, basically. Lean forward to go forward, lean back for brakes. There's some pre-built boards out there that do this already, but they're all kinda... Putting weight sensing pads on the deck trashes its ergonomics. And most weight sensors probably aren't rated for shock or vibration loads anyway, so they're not a reliable choice. The reliable choice here would be strain gauges. These are essentially little bits of wire that you glue down to the surface you want to measure, and as that surface stretches or compresses, the gauge stretches and compresses with it, so the wire gets longer or shorter. That changes its electrical resistance, which can be measured to a high degree of precision. These things are frequently used in the industrial and scientific worlds to measure the deflections and vibrations in structures. So, no moving parts, very robust. So here's how I'll put them to work on a skateboard. Boards flex because the distance between the points where your foot pushes down on the deck and the ground pushes back up on the board creates a moment arm that flexes the deck in that direction. Now, when something bends, its top surface is placed in compression, and its bottom surface is placed in tension. So, I'll place strain gauges at the top and the bottom of the tube, where these forces are the greatest, and then wire them up in a pattern known as a Wheatstone bridge. Which allows those very small differences in electrical resistance to be measured by an amplifier chip like this one. The output from all of those amplifiers will be fed into an Arduino, which I'll program to decide what to do based on those inputs and generate a throttle signal. And that program will basically boil down to read the sensors on the front and the back of the board, do some math based on the ratio between the sensor output at the front and the sensor output at the rear to figure out where my center of gravity is across the board. It will also need to decide whether the board should be armed or disarmed so that it doesn't do anything crazy when I step off of it. If there's not enough weight on top of the board in the first place, it should disarm, and if there is, then it should use that math to generate a throttle signal to send to the ESC. And then repeat that process as many times per second as it physically can. Okay, let's go. So now the control system is finished, a process which was completed with 0 delays or missteps. I've got this little red flag mounted on a servo motor just to show you what the throttle and brake signal is doing. As I step on the board, it arms itself. And as I start moving around, it tracks my movements. And then once I step off the board, it disarms. And that's it for now. There's plenty more work to do on the board to get it operational, but I'm afraid that it's all dreadfully conventional. And since I'm not really the right authority to be teaching you how to build a battery pack or anything like that, the next time you see the board, it should be rolling under its own power. So thanks for watching. I'll see you there.